Okay, guys, so I'm actually going to be working on the repeated measures ANOVA. Excuse me. When we were in class last Monday, that's Monday 28th, we worked on the ANOVAs, one way, two way, and three way. But those ANOVAs were solely on between subjects or those independent samples ANOVAs, meaning that the samples of participants were not the same people that were in all of the conditions. So each condition had its own set of participants. So no one repeated. What we're going to be doing in this video is the opposite. So we are assuming that the participants in each condition are the same set of people. Hence the term repeated measures ANOVA. This first one that I'm going to work on is the one-way ANOVA. And you can see here on the screen, I have a one-way, 3 levels. And if you remember the vignette I used last time, in the one-way we had 3 different types of drinks where people were going to test each one and see which one allowed them to stay awake longest when it came to reading something that was lengthy. All right, so now we're going to have each participant try each of these drinks. So we can say, for instance, this test may have been conducted over a 3-day period, and on each day we had participants try one of these types of drinks. So maybe Monday, they all tried coffee, the same amount of coffee at the same time. Then maybe the Tuesday, they tried tea, the same quantity, the same volume of tea. All of them tried the same volume on Tuesday. And maybe Wednesday, they all tried water. So each person is getting an opportunity to test each of these different drinks, right? And as you can see here, each row represents a person and each column represents a condition. This is a little different from what we saw when we were doing the independent measures version, where we had our data laid out in this fashion. All right. So here in the independent samples version, we had the data laid out in this way. But this does not show each of the persons and their respective trials. So this is why we are rearranging the data in the repeated measures version in this manner. So each row represents a person, a participant, and each column represents a condition. So this is, for example, person A tried coffee, they had 162 minutes. Tea, 154 minutes. Water, 58 minutes. All right, these values are the number of minutes that the person was able to do some extended reading based on the drink that they had. So here is the data, and now I'm going to transfer this into Jamovi for analysis. I'm going to highlight only the values, only the outputs or the outcomes, and I'm going to copy these. In fact, what I can also do, I can really copy all of those, including the participant ID. I'm going to copy this and paste it into my Jamovi. All right, so I'm now in Jamovi on the right side of the screen. I am going to make sure that I name my variables. So this variable is participant ID. Okay, and This is a nominal measure. Data type is text, and that would do fine. The next would be coffee. And this would be the minutes lasted from drinking coffee. Of course, this is a continuous factor, continuous variable, and we have them in integer form, so that would be all that we need there. Here we have t, and this is the number of minutes lasted from t. I'm going to put that as continuous. It's already integer. Next one, water. Number of minutes from water. Again, measure type, continuous, integer. Okay, so this is all we need for the insertion of the data, for the input of the data. Now we're going to do the analysis. I click on, let's start on exploration, do some descriptives. And of course, we're going to split each of these by participant ID. And so we have, see if I could make this a little bigger. All right, so this is what you have. All right, so I would stay away from this. I don't think it's worth much. I don't think the mean is really, the median is really required. And of course, you see here why this would not make much sense, right? I would not do a descriptives version of this way, right? So I did that to show you that it's not relevant that you do descriptives in this manner when you're doing the repeated measures. Okay, so that takes care of that. Let's go on to what we really are concerned with, and that's the repeated measures ANOVA. So I click on the ANOVA button, right? It's under Analyses, ANOVA, Repeated Measures ANOVA. There we go. All right, now, remember, we have only one factor here. One factor, one independent IV, one independent variable. And this factor is the type of drink. And under drink, we had these three levels. We had coffee, we had tea, and we had water. So notice I'm actually clicking in these spaces, typing in the words, and that's about it. We have all three here. Now notice as I was typing these in, the actual words were coming up in these boxes down below in the repeated measure cells. So now we have coffee, tea, and water based on the levels that I just wrote in. What goes in these spaces? Notice it says here in faint, drag variable here. I will be pulling the corresponding dependent variable measure into the respective spaces. So coffee would go in the coffee space, tea goes in the tea space, and the water goes in the water space. All right? And now I don't need anything for between subject factors, so that's not going to go there because we're not doing between subject measures anyway at this point. And we can leave covariance empty. So here we have the repeated measures ANOVA within subjects effects. So we can see here that drink is clearly significant. There is something with drink, which by the way, it's basically telling us that we have some significant difference when it comes to drink. Now, of course, this is based on each person trying the 3 different drinks over 3 days. So what one can deduce is that, you know what? Drink really matters because each person trying the three different drinks, clearly there's a difference between the drinks, and therefore that's what you're seeing here. Now, as with all ANOVA in the beginning, we do not know what the direction or the difference is really based on. First, to get that specificity, we need to get to the post hoc test. So I'm going to come down here, post hoc test, click on that one. And since drink is the factor that I have, I'm going to bring that across, make sure the two key post hoc is highlighted. And here we go. Under post hoc, we see here that when you're comparing coffee and tea, there is no significance. This p-value is above 0.05. When you're comparing coffee with water, p-value is less than 0.05. So clearly this difference is significant. And tea and water, you also have a p-value that is lower than 0.05. So tea and water are significantly different when it comes to students being able to last longer having ingested one of these. So we can now see the differences highlighted. Coffee and tea are significantly different than water. So that takes care of repeated measures ANOVA, one-way ANOVA. So let's look at some estimated marginal means. I will click on that button right here, the bottom left, scroll down, and I'm just going to pull the drink into that term 1 box. And of course, my marginal means plots are highlighted, and we will see the marginal mean plot come up here. So here we have marginal means. You can clearly see here that the coffee and the tea, they overlap, the error bars overlap, whereas compared to water, they are much higher and do not overlap. Therefore, you can see again the significance in difference between tea and water, and coffee and water, and tea and water. Okay, this takes care of ANOVA, repeated measures, one way. Okay, so now we're on to the two-way ANOVA. And just to refresh your memories, in our vignettes from last day, we considered what happens if we had coffee and tea being compared, but unsweetened and sweetened versions. So now what we really have here is a 2x2 factorial design. And of course, this is again repeated measures or within samples. So we're going to have the same participant appearing in all 4 conditions, as you see here. All right. So what do we do in this case? Again, we have rearranged the data. So in the repeated measures ANOVA, we have rows representing the individual, the participant, and you can see here what the participant's outcome was in each of these 4 different conditions. All right. So once we have our data laid out in this fashion, we're now able to copy and paste and transfer all of that into Jamovi. Notice I have a new untitled Jamovi here. Just going to copy and paste that. Of course, you can enter data directly into Jamovi. It's not like you always have to have it in Excel and then transfer it. Excel is certainly more comfortable for some people, and so it's good to at least have your data in Excel. At least it's good you have it backed up somewhere. All right. So now I can go rename my variables. A again is participant ID. I'm just gonna leave these a little simpler. So participant ID. All right, this is nominal. And we go to the next one. This would be our coffee unsweetened, COF_UNS. Right? It's good to not leave any spaces between the terms that you use, at least when it comes to naming the variables. In the description, of course, you write freely. So this is unsweetened coffee minutes. All right, again, these are the number of minutes that each person would have lasted after drinking the respective beverage. Next one we have is tea unsweetened. Unsweetened tea minutes. Of course, this is continuous. Next one, we have coffee sweetened, COF_SWT. And the last is sweetened tea. Oops, I'm going to put that in the description. This is T_SWT. All right. So now we have our variables named. Good. Let's close that up. And now let's go straight to our ANOVA. Just going to expand this page now that I don't need the data anymore. And you'll be able to see the Jamovi outputs much better. So ANOVA, again, repeated measures. And as we did before, we're going to put in our factors and levels. Now, of course, since we have two factors here, the first is the type of drink. And in each case, we have level 1, we can put coffee. And we have level 2, tea. Notice how these level names are appearing in the repeated measures cells down below. All right. Now, RM factor 2, we're going to have the sweetness. All right. And now, what am I doing to actually move off from this grade portion when I finish typing? I just hit the enter button on the keyboard, or I can click anywhere outside of the box. And that brings up space that I can bring down to see my levels. So now we have the first one was unsweetened. And the second one we have, of course, is sweetened. Sweetened. Good. So you can see where we have our two factors, each with two levels. Right? You can see RM factor 3 peeping up here for our three-way ANOVA. We're not going to get to that as yet. That will come afterwards. So now here we have our 4 different conditions. Coffee unsweetened, coffee sweetened, tea sweetened, unsweetened, sorry, and tea sweetened. Like we did before, for the one-way ANOVA, we are going to bring the corresponding dependent variables to their corresponding section. So coffee unsweetened goes here in the first one. Tea unsweetened goes in the third one where it's named. Coffee sweetened goes in the second space, and tea sweetened goes in its corresponding space at the bottom. Again, we do not have any between subject factors. That's not necessary here. And as you can see in the output area, our ANOVA table has been generated. So what are we seeing here? We see in terms of drink, there is some significance. The p-value is less than 0.05. So we do have some main effect of drink. All right. And you may ask, well, what are the hypotheses for these ANOVAs? Remember the same hypotheses we had for the last class when we had the independent samples, these can be modified for here as well. So we have drink as a main effect, the first factor, and clearly there is an effect of the means of drink on the outcome. So we have this here is a main effect of drink. There is also a main effect of sweetness. So clearly, factor is playing a role in the outcome. Sweetness, sorry, is playing a role in the outcome. Now, when it comes to the interaction between drink and sweetness, there isn't any significant effect of the interaction. So the asterisk, as we mentioned before, that is your interaction indicator, and there is no interaction of significance in this case. All right, so again, where are these differences in terms of drink and sweetness being revealed? Well, we can first go to our post hoc test section, and we're just going to bring all of these over to the right side. We have drink, we have sweetness, and we have drink times sweetness. Notice I'm just clicking on it, left click, and dragging them over to the right side box. And as we did that, you have the corresponding post hoc tests coming up. So clearly there's a difference between coffee and tea. We already saw that. There is a significant difference in sweetened versus unsweetened. We saw that. And here are the comparisons when you do the combination. So is unsweetened coffee significantly different to sweetened coffee? Yes, it is. Here's your p-value, which is less than 0.05. This is actually 0.005. So again, it's lesser than 0.05, meaning it is significantly different. Coffee unsweetened versus tea unsweetened, there is no significant difference there. Coffee unsweetened versus tea sweetened, there is significant difference there. Coffee sweetened versus tea unsweetened, no significant difference. Coffee sweetened versus tea sweetened, no significant difference. Tea unsweetened versus tea sweetened, there is significant difference there. All right, there's 0.032, and that is certainly less than 0.05. So we have significance in that last one. Estimated marginal means output. We can now drag drink, which was term 1, and unlike the one-way ANOVA where we had only one factor, in the two-way ANOVA we have two factors. So we're going to click on add new term, and here you have a term 2 box that appears, and now we can drag sweetness over to that second space, and we have our marginal means plots being generated at on the right side here. You will see the estimated marginal means for drink, and that shows you that there is some sort of significant difference there, although it's not readily visible in this plot because the error bars do overlap considerably. So this is the reason why we cannot rely solely on seeing what happens with the error bars and overlaps. Normally this would suggest that the distinction is not significant. But as we saw earlier on, there is significant difference, right? 0.02 is less than 0.05. So there is significant difference in the type of drink. We saw that again when we did the post-hoc comparisons. So if these are the values that we're getting in the calculations, we have to go with those over what we're seeing here with the plots. Similarly with the sweetness, now these are more distinct. So you can see here that one might be even more inclined to believe this plot because you don't see any overlap, which means significance. And this is borne out by the numbers as well as we saw here and up here. Good. So this takes care of the two-way ANOVA using repeated measures analyses. Okay, so now we're on to the last of the three types of ANOVAs. We're going to do the three-way ANOVA and, of course, repeated measures again. This time we have three factors and two levels each. So what's happening here? Well, we can imagine that these 10 participants are each going to be exposed to what we have as 8 conditions. Of course, 8 conditions because you have 3 factors and 2 levels in each factor. 2 to the power of 3 or 2 times 2 times 2 gives us 8 conditions. What are these 8 conditions, you ask? Well, let's build on what we have done so far. We know that we had coffee and tea being compared. In the two-way ANOVA, we did coffee unsweetened and tea unsweetened, coffees sweetened and tea sweetened. So you had type of drink and you had amount of sweetness. Now, we're going to add a third factor. So it's not just drink, coffee or tea. It's not just sweetness, sweetened or unsweetened. Now you have type of shot. Is it a single shot or double shot? All right. So we have here in the first column, coffee that is unsweetened, you have a single shot. SGL is the abbreviation for single. DBL is the abbreviation for double. And you can see coffee unsweetened single, coffee unsweetened double, coffee sweetened single, coffee sweetened double. And then you have the same 4, but this time for tea. So what I'm going to do is, as I did before, highlight all of the relevant data, post it in my Jamovi, and I am going to rename my variables in Jamovi. Again, I'm just going to keep it short so that I can keep this video as short as I can. It's already 27 minutes in. Hope you're sticking with this. Okay, so that's nominal. We leave that as such. Next variable, click on the little arrow, takes us to variable B, and that is coffee unsweetened single, COFUNS_SGL, right? Coffee. You know what? You get the drift with the descriptions. I'm not going to fill those in. It's not necessary at this point for the cases for the purpose of the video. But of course, when you're doing this on your own, you should put in your description that is clearly identifying what the variable's name represents. So I'm just going to skip that for the sake of keeping the video as short as possible. This one is coffee unsweetened double. This is coffee sweetened single, continuous. This one is coffee sweetened double. Change to continuous. Now we have the T's, T underscore unsweetened single, T underscore unsweetened underscore double, T T underscore sweetened underscore single and last but not least we have T underscore sweetened underscore double. Okay, so now that we have identified all of our variables, we go straight to the ANOVA, repeated measures ANOVA. Let's expand this window so we can see everything. And as we did before, we're going to fill in our factors. The first factor was the drink factor. And in that we had coffee and tea. What am I using to get from one level to the next? I can either use my mouse or I can use the tab button on the keyboard. That's what I'm using. I'm using the tab button. I go to RM factor. I'm using the mouse for that one. Obviously, I'm clicking there. And the next one was sweetness. And the levels there we have were, scroll down, we have sweetened and unsweetened tab. Okay, scroll down, click on RM factor 3, and we have shots. So you have the single shot. It doesn't matter what the level alpha, we can delete that. Single and double. Okay, so now we should have all 8 conditions showing up. So let's fill in the corresponding spaces by dragging over our DVs. Coffee single unsweetened. Coffee single unsweetened. Yes, that goes there. Right. Be very careful as to which variable you put in the corresponding space. Be very careful, especially when you have so many at this point. This is coffee unsweetened double. We go to coffee unsweetened double. Here we go. That's right there. Coffee sweetened single goes at the top. Coffee sweetened double goes here. Right? Based on how you enter them in the repeated measures factors table above, yours may differ from what I have here. So be very careful to drag the respective DV output into the correct space. Okay, T unsweetened single, that's going to clearly go down here. All right, so notice I'm not seeing, so I need to bring that down a bit. I need to come over here, click and drag it down. And now that I have all my T's highlighted, I can bring them over. T unsweetened single, it goes there. T unsweetened double. Oops, see, I made a mistake. T unsweetened single goes down here. Very good. T unsweetened double goes in my last box down there. T sweetened single goes here. And T sweetened double goes here. I'm just going to make sure that everything was done correctly. Coffee sweet single, coffee sweetened double, coffee unsweetened single, coffee unsweetened double, tea sweetened single, tea sweetened double, tea unsweetened single, tea unsweetened double. Okay, good. Again, nothing in the between subject factors, no for covariates. And we see here, this is our output in the ANOVAs table. So, do we have any significant outcomes? Well, we see sweetness is at 0.037 p-value. That is less than 0.05, so there is significance of sweetness. There is a main effect of sweetness. Likewise for shot, there's a main effect of shot. There is some impact that the shot is having on the outcome. So in terms of null hypotheses, sweetness and shot, you would have to reject the null hypotheses for those main factors. Is there an interaction between drink and sweetness? No, there is not. That's clearly above 0.05. Everything else here has a p-value of greater than 0.05. So there is clearly no other significant outcomes except when it comes to sweetness and shot. So they're the only two significant differences that we see. Again, we're going to go to our post hoc tests and we can bring everything over. I would just bring drink, sweetness, and shot, so it will give us that sort of all-inclusive post hoc. So here we have the post hoc with all three factors. And what do we see? We see coffee sweetened single. So a single shot of sweetened coffee is significantly different in terms of longer lasting time in reading than sweetened double coffee. So you can see here that this is where the shot was playing some significant role. Remember, we saw shot as being significant in terms of differences. And you can see it right here. The sweetened coffee, the single shot is different than the double shot. All right. Likewise, we have single sweetened coffee is significantly different than coffee unsweetened and single. So again, here, the sweetened versus unsweetened is playing a role in the outcome. As you see here, sweetness, there is a significant effect. And you can go through all of these other comparisons to get all of the differences where the two key p-values are less than 0.05. I won't go through that for the sake of ending this video at this point. So the last bit I'll do, of course, is the estimated marginal means. We have three factors, so I'm going to just click and add spaces for two more, and I bring drink over in the first space, sweetness in the second, and shot in the third. These need not have been in this order. We could have put shot first, drink second, sweetness third. Doesn't matter. All that really matters in this case would be the plots that you see appearing on the right. And each would have a plot for the different factor. All right, so let's give these spinning wheels of death time to materialize, and we'll see. There we go. So you have drink. Again, the plot says here that the relationship between coffee and tea is not that significantly different. We saw that in the output, where the p-value was above 0.05, and that is borne out as well by the plot. But as we saw last time, the plot does not always tell the calculated story. So in this case, the plot is mirroring what we saw with the output. Sweetness, they do overlap slightly, but as I said, we're going to trust the p-value more than we would trust the plot. And so in this case, we have to go with the sweetness being significantly different in terms of outcomes. And we see it's even more apparent with shot. And I think maybe that's why the disparity that you see on the estimated marginal means plot is sort of borne out by the extremely low p-value when it comes to the shot. Okay. All right, guys. So this is, wow, 40-minute video. I hope this was helpful to each of you. This would certainly help you with MP5.